Stan Gibilisco here to show you how you can simulate the functioning of a logical AND gate using two diodes, rectifier diodes, a 1/2 watt 470 ohm resistor, and a 6-volt lantern battery. These are all you need to simulate that particular situation. Just connect them up like this. When you want to make an input high, ground it. When you want to make it low, ground it. When you want to make it high, simply connect it to the positive voltage terminal of your 6-volt lantern battery. So let's look at what happens here. Now remember, at an AND gate, the output is high if and only if both inputs are high. If either or both inputs are low, the output is low. So let's start with X low and Y low. Basically what that means, if you do that, is you're grounding both X and Y. And what you get then, in effect, is current flowing through these diodes to ground from the battery. That's what we have this 470 ohm resistor here for, because if it weren't there, these diodes would likely burn out. Not only that, it would place a tremendous strain on the battery. This resistor has to be sufficient in value so that it itself will not burn out. But once you've done that, what happens is you basically get short circuits right here and right here to ground. So the output Z is low. These two are low, that one is low. If either one of these two, X or Y, are low, then current will flow through the diode to the one that's shorted to ground, and you will in effect get a short circuit to ground right here and get a low. If you have, for example, positive 6 volts here, then you will get no current flowing through this diode whatsoever, positive 6 volts, but it'll still be shorted to ground through this diode, and similarly if you switch them around. So if either input is high, you will get a high at the output Z. No, pardon me. If either input is high but not both of them, you will get a low at output Z because it will be shorted to ground through one or the other of the diodes. Now, if you happen to have both inputs high, plus 6 volts here and plus 6 volts here, then no current will flow through either diode. You might as well just not even have them there, and this positive voltage will get right onto that terminal Z or Z, and you will get a logical high here. So that's how this arrangement of very simple, discrete analog components can simulate the operation of a digital AND gate. Build this little thing, try it and see, and Stan Gibilisco will be watching you and laughing when you make a mistake and burn something out. Until next time, so long.